Education Society, redefining excellence.
Hi everyone, my name is Amol Ghadke. Today we will learn about an earthquake resistance technique. So first we will learn about what is earthquake. They are natural disasters of generally unpredictable nature. Sudden movement surface of the earth may be tiny or several feet. A sudden and rapid shaking of earth caused by the breaking and shifting of the rocks beneath the earth's surface. There are some following terms. First, fault plane, then hypocenter, then epicenter. There is one interesting fact about earthquake. When such quakes happen, enormous amount of energy is released, which is far greater than big nuclear bomb. There are some popular earthquake resistant techniques, which are conventional methods: shear walls, bracing, seismic dampers, isolation, bands, lightweight material. First, conventional methods. The concept is to strengthen the building, have stiffness and inelastic deformation capacity. Some of the general design concepts follow current earthquake standards and codes, provide strong foundation, use best quality materials, avoid irregular shape structure and framing system, maintain integrity by providing seismic bands. And there are some remedial measured for soft storage buildings. First diagram shows that bracing in columns of open ground storage. Second diagram shows that providing RC shear wall, and last diagram shows that providing brick in fills between columns. Next is shear walls. It is vertically oriented wide beams. It carries seismic loads down to the bottom of foundation, provides large strength and stiffness to buildings. Thickness generally varies from 150 mm to 450 mm in high-rise buildings. Should be symmetrical in plane along both the axes. The opening provided in shear wall should be symmetrical, effective when located along the. In this picture we can see the RC shear wall foundation, and at the corner we can see the plan. Next is bracing, system utilized to reinforce building structure in which diagonal supports interest. Cross bracing is usually seen with two diagonal supports placed in X-shaped manner. Under lateral force, one brace will be under tension while the another is compressed. Brace frames are primarily utilized as lateral load resisting system. In the following diagram there are some bracings. First is V bracing, then is inverted bracing, means opposite. There is diagonal bracing, X bracing and K bracing. This is energy dissipation device, seismic dampers. This diagram shows energy dissipation device. These are used in place of structural elements such as diagonal brace. Acts like the hydraulic shock absorbers in cars and is usually used for protecting tall buildings. When seismic energy is transmitted through them, dampers absorb part of it and thus damp the motion of the building. There are some types of dampers: viscous dampers, friction dampers, and tune mass dampers. Viscous dampers reduce the vibration by fluid action. Friction dampers reduce the vibration by rubbing at surfaces. Tune mass dampers reduce vibration by harmonic action. Next is base isolation. Lead rubber bearing in is sandwiched between two plates. Base isolated structure is supported by a series of bearing pads which are placed between building and building foundation. Reduce the building acceleration by one fourth the acceleration fixed base building. Acceleration decrease because the base isolation system lengthens the building period of vibration. Rubber is highly elastic, so reduce the damage. Here in this picture we can see fixed base building and isolated building. Next is bands. Horizontal bands are most important earthquake resistant feature in masonry buildings. They hold a masonry building as a single unit by tying at all the walls together. In this picture we can see the gable band, roof band, lintel band, and at the bottom we can also see the plinth band. Last is lightweight material. Lightweight material reduces the dead load of the material. It reduces the effect of seismic inertia forces. Some materials are lightweight aggregates are fly ash bricks, autoclaves, aerated concrete, gypsum based ceiling tiles, autoclaved aerated blocks, rice husk, etc. There are some suggestions Avoid weak columns and strong beam design. Provide cross walls which will thicken the structure. Provide thick slab which will help as a rigid diagram. Provide shear walls in symmetrical fashion. Increase in the transverse reinforcement. Horizontal lintel band should be provided. Revision, updation of Building Code of India. The building must be regular and symmetrical in shape. Reinforcing bars should be provided at the corners and junctions of the walls. Next are the conclusions related to earthquake. The work in the field of earthquake resistant technique is very important to have safe structures. Techniques of earthquake resistance are not to strengthen the building but to reduce the earthquake generated forces acting upon it. Effects made by earthquake mainly depend upon acceleration of base and mass of building. In this paper, a number of traditional and modern techniques have been discussed which are adopted in construction practices for improvement in the earthquake resistance of a structure. Earthquakes do not cause damages, it is the building which causes damages. It is the responsibility of structural and civil engineers to design and construct the building according to the standard codes and should ensure proper quality control. Next are some references relating this project. Thank you.
Zeal Education Society. Redefining excellence.